Okay, now from today onward and till next 20 to 25 days, we will discuss about the topic center of mass, linear momentum, and collision. Okay, and each word and written in this topic are very important. Okay, so today we will introduce you to word center of mass and what is the concept, elementary concept. Okay, and then in next 3 and 4 day we will study different aspects of center of mass. Okay, so to understand center of mass we will first give you some example what to, so that you could imagine and you could have some idea what is the center of mass. Okay, so suppose a spin bowler throw a cricket ball, okay, in vertically upward direction. So let me show you some figure. uh, okay, yeah, so suppose uh, okay, so this is an spin bowler and who has throw a cricket ball in vertical direction. Okay, vertical direction. And so since he is an spinner, so his finger turn, okay, while throwing the ball, and ball goes up spinning rapidly. Okay, so this ball. So and if we going to focus, if we are going to focus on a particular point like this point, okay, consider this point P. If we are going to focus on this particular point P, uh, which is on the surface of ball, so how does this point P will move in space? We want to know how does this point P will move on space. Okay, and to understand this we should realize two things, that this ball is moving upward, this point is moving upward, and while it is rotating. Okay, while it is rotating, and you know in general the path which along which this point P will move is something like this. Okay, is something like this. Okay, let me draw that path, and let's suppose this is the vertical line, this is a vertical line, and this path will be something like this. Okay, this path will be something like this. Okay, okay, so this is not a straight line, or it is neither confined in a plane. Okay, this is not a straight line, or it is neither confined in a plane. And but one thing is that the center of this ball, the center which is inside this ball, is not going to rotate. The center of ball is will go on a straight line, on a vertical straight line. Okay, what I'm saying, we just we it so center of the ball will go on a vertical straight line. Okay, which will go on a vertical straight line, and and the finger of spinner could not make its path complicated. Okay, the finger of the spinner is could not make this part complicated. Okay, okay, now let's see another example. We'll discuss all these things, whatever query is in your mind, don't bother. Yeah, suppose you rather throwing the ball in vertical, he just throw the ball, the spinner throw the ball, he throw the ball to his another friend. Okay, he throw a ball to his another friend. So the the point which is on the ball surface will move in along this complicated path, okay, while again the center of the ball will move, this along this, which is going darker and darker along this line, okay. Could you see? Along this line it is going to move along this line, okay. So where it is, okay. So there on this parabolic path, okay, it is going to move on this parabolic here, on this parabolic path, okay. This parabolic path, the center, okay, what I'm saying, the center of the ball will move on this parabolic. It is not going to move on a complicated path, okay. Okay, let's see another example, okay. And the example is, let me show the picture here. See here, okay. And let's suppose this is, okay, okay. So this let's suppose this is a battens like thing, okay. And a juggler throw it in air. So listen here, this point, if the point here is move along this in this manner, okay. Look, see here how the motion of this point is, okay, how complicated the motion of this point is, okay. But the center of mass, the center of mass, okay, can you see? Center of mass will move along a fixed line, along a parabolic path. The center of mass of the ball, center of mass of this batter will move along a fixed parabolic path, okay. Sorry, the point, this point, okay. So I should not, forgive me, I say center of mass, but this point, this darker point P, this point, okay, this point will follow a fixed parabolic path, okay. This particle is not going to follow, this particle is also not going to, particle here is not going to follow, this particle at here is not going to follow the parabolic path, okay. But this point, okay, this point is going to follow a parabolic path, okay. You can see it, how path of this point is, okay, how path, initially it is here, then it is here, then it is here, then it is here, then here, then here, then here, then here, and then it goes something like this. It is not a parabolic path, okay. So but here, okay, the other particle is not going to follow a parabolic path, but this point which is black dark, okay, is going to follow parabolic path, okay. So where is, okay, okay. And so here, you should realize two things, that all the point of this cricket ball do not go in parabolic path, okay. Do not go in parabolic path, okay. On do not go in a parabolic path in case the fielder throw the ball, or they not go in vertical path in case the spinner throw the ball in a vertical direction, okay. Okay, and another thing is, if ball is spinning, then most of the point path of most of the point goes on a complicated path like this, okay. This is a complicated path, most of the point goes on complicated path, but the center of the ball always go on vertical line, if on a vertical path, okay. If the spinner throw the ball in a upward direction, okay, vertical upward, and if he throw the catch, okay, he throw the ball to his another friend, then it will follow on a parabolic path like this, center, okay, not all the particles, center will follow. Okay, where is my dark, let me write, yeah, here. So here the center will follow on this parabolic path, not all the point. Okay, so and we had neglect the AR etc whatever it is. So so for calculation point of view and for physicist point of view, the center of the ball is a very special point. The center of the ball of cricket ball is a very special point, and we call that point as a center of mass, and its motion is just like the motion of the single particle throw. Okay, so note down these things, note down these things. So we should note down these things is that uh, center of mass, center of mass is center of mass is just like center of mass motion is just like motion just like motion of a point object, of a point or single particle. Okay, of a point or single particle object. Okay, so these are the very important. And there are so many things which come in your mind. The first thing is why the center of mass, follow behave like this. First thing, why center of mass behave like this, and second thing is how we will find that center of the sphere, this sphere will be that point whose motion is not going to affect. Okay, and how we'll find that this point, motion of this point is not going to affect this. It means that this point is a center of mass. How we'll find? Okay, you know what I'm trying to say. How you will calculate that this point will be a center of mass. Okay, how will you calculate? We'll learn these things. Okay, so we will learn these things. Okay, so just wait some minute. Okay, so okay, so and another thing is we should know is that whatever example I had given to you, the ball and the ball and the baseball, right, whatever, or baton, all of these has continuous mass. What it mean that look at the mass of these things. Look at this. Here it has this point has also some mass, this point has also some mass, this point, it is not that here is the mass and here is the mass and between them there is no mass. Okay, so such thing in which at every point has a mass is called continuous object. Okay, is called continuous object. Okay, and there are so many possibilities that you'll got a discontinuous object. For example, this discontinuous mass distribution. For example, just think about situation. Here is a sand particle. Okay, sand particle, just we can assume sand particle like a particle at a point mass. Okay, here is a sand particle, and another sand particle is at this point, another sand particle is this point. Okay, so this is not a continuous mass distribution. Okay, this is not a continuous mass distribution. Okay, this is discrete mass distribution. Okay guys, so to make this thing simple, to understand the concept, we will first try to find out what should be the center of mass of this continuous point. Okay, first we learn how we can calculate the center of mass of these discontinuous points. Okay, and these continuous point masses, and after that when we become bond on these things, then we will learn how to calculate center of mass of continuous object. Okay, for example, we learn how we can find that the center of this sphere is the center of mass. How we will find that this point, how we'll find that this point will be the center of mass. Okay, we'll calculate all these things. Okay, and these are some very simple basic calculation. Okay, so first thing, we are going to define a center of mass. Okay, so let's start. How we'll calculate center of mass. Okay, so suppose there are n particle. Okay, and they are distributed discretely in a space. Okay, in a space. Okay, these are the 3D space. So this is center of mass. Okay, these are the coordinate axis. This is x, this is y, and this is z, which is out of the plane of this laptop. Okay, this board. And okay, so let's consider there are some masses distributed, like here all masses are distributed. Okay, here, here, all the masses are distributed. Okay, there are n particle, n particle, n particle, and I particle, I particle has I particle has has I particle has mth ith mass. Okay, I particle has ith mass, and its position is coordinate. Its position is okay. Its position is xi, yi, and gi. Okay, this is the position. So let's suppose this is the ith particle, and this position is xi, yi, and gi. Okay, this is the position. So so center of mass. So you should use one thing you should know is the center of mass is a point. First thing is center of mass is a point. First thing, center of mass is a point. Okay, so it is a point, then it has some position in a space. So if center of mass is a point, center of mass is a point, then it has some position, some position in space, some position in a space, okay, it has some position in a space. Okay, if center of mass is a point, then it has some position in space. Okay, so what is our job is to find out the coordinate of that point. Okay, what is our job? Our job is to find out the coordinate of the point. So we want to know the coordinate. We want to know the coordinate. We want to know coordinate of that point. Okay, of that point. Okay, we want to know the coordinate of that point. Okay, so just go to a new page. Okay, so what will be the x coordinate? X coordinate is, okay, if this is the this is the x coordinate of center of mass, then this x coordinate will be summation of, okay, this sign is summation mi xi. Don't bother if you are not going, if you are not able to understand what is mean. I will, okay, I is equal to 1 to I is equal to n divided by summation of mi. Okay, I is equal to 1 to I is equal to n. So this is the center x coordinate of center of mass. Similarly, y coordinate of center of mass is, y coordinate of center of mass is summation of mi yi divided by summation of mi. Okay, and z coordinate of center of mass is summation of mi zi divided by summation of mi. Okay, so these are the, okay, so okay, guys, and in other word, what we can say that, what we can say that, you know if r is, you know if ri is position vector, if ri is the position vector of ith particle, then then what is the position vector of center of mass is, the position vector of center of mass is basically summation of mi ri divided by summation of mi. Okay, so summation of mi ri. Okay, and with the help of, and if you with the help of simple analogy, you are able to derive this. Okay, I am not going to do it by yourself. With the help of simple analogy, you are going to derive it. Okay, guys, and they are the very simple, you should do it by yourself. Now we are going to learn these things with the help of some simple example. Okay, some simple example we will discuss here. Okay, so suppose, okay, so some of the things you should who had become clear in your mind, that is that the center of mass for this this involve along a coordinate axis, some coordinate axis, some position vector, position, okay, geometry etc will be involved in it. Okay, so okay, so let's uh, try to understand the things with the help of some simple example. Okay, suppose this is x axis, this is y axis. Okay, and here is a mass, here is a mass m2, and here is another mass which is m1. Okay, and this length is from here to here is x. This length is x. Okay guys, this length is x, and here this length from here to here is l. Okay, here m2 is equal to 2m. Okay, and m1 is equal to m. So what is the center of mass? So okay, so what is the center of mass? Okay, so how many particles is here? So find center of mass. Find center of mass. Center of mass. So we have to find center of mass. Okay, so first thing, how many particle is here? How many particle is here? You'll see here there are two particles. One particle is here, which is m2, and first particle is here, which is m1. Okay guys, so here there are two particles. So it has two particles. It has two particle. Okay, and okay, now, so first particle is this is my first particle, this is second particle. Okay, and now, so what is the coordinate of this point? What is the coordinate of this point? You should write the coordinate of this point. So the coordinate of this point is the length from the origin. This is the coordinate. Okay, so this length will be x plus l. X plus l, because from here, from origin to this is x. Okay, let me, so this is the x. Okay, and from here to here, this is the l. This is the l. Okay, you can see it clearly. Okay, so, and what is the coordinate of this point? Coordinate of this point is this length, which is x. So this, okay, so this is x plus l, 0, which is the y coordinate, because perpendicular distance in y is 0. And what is the z coordinate? Z coordinate will be also 0. Okay. And here, what is the coordinate of this point is? Coordinate of this point is x, 0, 0. Okay, okay, now, so what is the position of x coordinate? Okay, what is the position of x coordinate of center of mass? X coordinate. Okay, so here xi will be xi will be, okay, mass m1, position of m1, position of this particle into its mass, position, which is the x plus l into m. Okay, plus this mass of this point, which is 2m, which is m2, which is 2m, into its position, which is x, its position, which is x. Okay, into x. Okay, divided by mass of this particle, which is 2m plus m. Okay, so if you look at this carefully, it is m, this is 3x. Okay, this is 2x plus x plus l, divided by, if you see, so do it by yourself. What you get, what is the position is x plus l by 3. What is the position is x plus l by 3. So this is the center of mass. Okay, what is the position of center of mass is? Position of center of mass is l by 3. Okay, this, okay, this will be the center of mass. Okay, so this point, so this is the center of mass. Okay, so motion, so this point which is between them is just behave like a particle. Okay, just behave like a particle. Okay, you got it? Listen here, here, you know, there is no mass here, there is no mass here, there is no any mass, okay, but center of mass is between them, okay, between them. Here there is no actual particle, but you know, motion of this point, you know, in complicated cases, motion of this point will be just like a point object, just like a point object, single particle, okay, just like a single particle. So, and what do you assume, that whole mass is concentrated here? What do you assume, that whole mass is concentrated at that point, okay. Now let's try to find out, solve another question. Which is as follows. Here, this is the m1, this is the m2, and this angle is 45 degree, okay. Here m1 is equal to m, and m2 is equal to 2m. So again, we have to find what is this position of the center of mass, okay. We have to find what is the position of center of mass, okay guys. So you know, first we have to determine the coordinate of this point. What is the coordinate of this point? Is 0 0 0. What is the coordinate of this point? Is, okay, this length is L, this length is L, so this will be L by root 2, L by root 2, okay. This, okay, this length will be L by root 2, and this length will be L by root 2. So coordinate will be L by root 2, L by root 2. So okay, so and okay, so what is the x coordinate? X coordinate will be 2m into position into 0 plus m L by root 2 divided by 3m, okay. So if you look at this carefully, what this become? L by 3 root 2, okay. And again, if you look at this, what is the y coordinate? Y coordinate will be same thing, will be L by 3 root 2. And what is the z coordinate? Z coordinate will be m into 0 plus 2m into 0 by 3m. So this will be 0. So coordinate of center of mass will be L by 3 root 2, L by 3 root 2 and 0, okay. These are the coordinate of center of mass, okay. This will be the coordinate of center of mass, okay. So what does it mean? That you know, we can assume that whole mass is concentrated at this point, whole mass is concentrated at this point, and you know, it will move, and this point, whole mass is concentrated at this point, and it will move just like a single particle, just like a single particle, single point particle, okay. Okay, so now let's consider another example, okay. Just wait. Okay, so now let's consider another example which is just similar to this one. So okay, so this is the x-axis, this is the y-axis, and you know, and at axis, and here is a 1 kg particle, okay, and another particle which has mass 2 kg, and the particle which is at mass 2 kg, this is 2 kg, and this located, and this distance is 3 meter. This distance is from here to here, this distance is 3 meter. Okay, we have to find out what is the position of center of mass. We have to find out what is the so what is the first thing we have to determine the coordinate. Okay, so the coordinate this point is 0 0 0, and the coordinate this point will be 3 0 0. Okay, so we have to find out what is the x coordinate of what is the x, what is the y, and what is the z coordinate. So what is the x coordinate? X coordinate will be 0 into 1 plus 3 into 2, okay, divided by 1 plus 2, because this is 1 kg, this is 2 kg, so 1 plus 2, so this will become 2. Okay, what is the y coordinate? Y coordinate, if you look at this, 0 into 1 plus 0 into 2 divided by 3, so it becomes 0. What is the z coordinate? Z coordinate will be similarly, z coordinate will be 0, because 0 into 1 plus 0 into 2 divided by 3, this will be 0. So so what is the coordinate of center of mass? Coordinate center of mass is 2 0 0. So 2 0 will be somewhere here. Okay, 2 0 0 will be somewhere here. This will be the 2 0 0. Okay, this will be the 2 0 0. Okay guys, so this is the method. Okay, this is the actually you had so many, you may think that okay, this is the correct, but how could we find the center of mass of continuous particle? So just wait, we will learn all these things in next lecture. Okay, and we'll solve some more example and some more question on discrete problem. Okay, discrete particle. Okay, thank you for watching.